So this is on page 327 of your textbook. This is dividing rational expressions. And ultimately, what I would tell you, everybody, is everything we've done so far, that's a bit of a lie because, we had that little detour where we had to talk about non-permissible values when you have two variables. But pretty much everything that we've done so far turns into simplifying a rational expression. So far what we've done is we have learned that when you're simplifying or multiplying rational expressions, everything gets factored and any factor on the top and the bottom get canceled if they're equal. So you'll notice I said when simplifying or multiplying, because when you're multiplying, if I have the following rational expression with the following factors being multiplied by the following rational expression with these factors, when you multiply fractions, you multiply across the top and the bottom. So this that you're looking at right here is no different mathematically than that. Right? So you have two rational expressions you're multiplying. The reason why we can cancel factors that are common is because really it's just one big honkin' rational expression. That's all it is. It's not really two. I mean, it is, but we make it one. The only thing we learned beyond that is that when you're dividing, you change the problem to multiplication by multiplying by the reciprocal, which if you think about it then, as soon as you do that, you're doing this. It's all about factoring and canceling. The other thing that I want to point out here, just to remind you, is that when you find your non-permissible values, you always find them after you factor, but before you cancel. I mean, you can find them after you cancel. You just have to look at the ones that were there before they got canceled. So that's it in a nutshell. By the way, non-permissible values are found using denominators of everything and the numerator of anything that you're going to flip over. The numerator of anything that you're going to divide by. So does anybody have any questions you would like me to go over? Go ahead, Shannon. 8D? Certainly. Looks like a beast of a question. Just want to make sure that one, right? Okay. So I'm just going to rewrite it even though I could factor it at the same time. I just like to see the whole thing. And by the way, I don't want to factor anyway because I want to flip before I factor. Or I want to factor then flip. But don't do them both at the same time. I can't remember. Yesterday did I flip and then factor? I factored first, eh? I guess, and that makes sense because what have I told you to always do first? Factor. But I'm going to rewrite this. It's divided by now. We have 2y squared minus 3y minus 2 over 2y minus 2. And then we also have divided by 3 minus 4y over y plus 1. Just step back and look at all of that. Looks okay. I have a question for everybody here. How many of you recognize something off with this factor? Something different about it. It's that the y's are negative instead of being positive at the front. Keep that in mind. So now I'm going to factor everything first, Shannon. I have a complex quadratic trinomial. I've already looked at these numbers to see if I can take out a common factor, and I can't. So I'm stuck with factoring this, and I'm going to guess it's 2y and 4y. Then what I'm going to do is try 3 and 1, and it's hard for me not to look at that middle term. But I'm going to not look at it and just say I'm going to try the 3 in the first one and the 1 in the second. Because some of you are probably like me. As soon as you look at that middle term, you pretty much figure out where they go. But I'm supposed to be teaching all of you, so not everybody is like that. When I do that, my outer, and this is really everybody just scrap work. My outer, that's an O, is 4y. My inner is 6y. Oh, I hit the jackpot. I want negative 2y. So if the 6y is negative, that would give me negative 2y. To make the 6y negative, I have to put a negative there and a positive here. Over, so again, this is just scrap work. Y plus 1, y minus 1. And I think it's important, as I say, it's just scrap work, for you to understand, I don't expect to see ever any explanation as to how you factor these things. Okay. Divided by, well, this is going to be 2y and y. Do you see, everybody, that it has to be 2y and y? It's the only way you're going to get 2y squared. By that same logic, the only way you're going to get a 2 over here is to have a 2 and a 1 as well. But I can't put the 2 for this 2 with the 2 for this 2. I can't do that, because then I have a common factor of 2. I mean, I can try it, and it just won't work. So that's kind of telling me that there's only one way to factor this. Little bit of thought, are you okay with the negative going in the second one? That will give us negative 4y for the outer and 1y for the inner, and we want negative 3y. I can factor out, be careful here. You can still factor this, even though it's just a binomial. You can factor out a 2. And I don't know that this is a hard and fast rule that you need to follow, but I think it's good advice. That factor at the top that was off, when you have a factor, a binomial factor, and the variable is negative, I would recommend factoring out a negative 1. And I'm going to actually just show this up here. If I factor out a negative 1, the 3 becomes negative, the 4y becomes positive. In other words, factoring out the negative 1 flips these two terms around. And now it's something I can deal with. And I think you can kind of look ahead and see that we have a 4y minus 3 over here. So something's going to happen there. There's going to be some action. And then on the bottom we have y plus 1. Really, I've said this before, and I say it a lot in Math 30 and 31. Your work in algebra needs to be slow. Not so slow that it takes you forever, but it needs to be deliberate and thoughtful and organized. And all of those good work habits need to be in play. If you're all over the place in your head and on paper, it's hard not to make a mistake. I mean, it's hard enough not to make a mistake anyway, right? And I've always said that. You're going to make mistakes in math. Now I can flip things over. This I'm not dividing by this, so it's 4y minus 3 and 2y plus 1 over y plus 1, y minus 1. I'm going to flip over the second one and change it to multiplication. So I'll have a 2 and a y minus 1 on the top, and on the bottom a 2y plus 1 and a y minus 2. Step back and look at that. Sure, that looks okay. This I'm also dividing by, so I need to multiply by the reciprocal. I have y plus 1, which you certainly don't need brackets around it, but I want to drive home the fact that the y plus 1 is a factor, over negative 1, which is a factor, times 4y minus 3. And I'll just double check everything. And I'm doing it because I'm, teaching you, but you should be doing it when you're doing the math as well. I think it looks fine. So now we go on a hunt for things we can factor. I did see a 4y minus 3 on the top and the bottom. I know there was another y plus 1. I have a y minus 1. I have a 2y plus 1. Man, not much survives, eh? I get a 2 on the top and a negative 1 on the bottom with a y minus 2 on the bottom. And that's our answer, but did I miss anything or I got them all? I think I got them all. But I would probably do that. The only reason why, it's the opposite of what I got up here in green. When you take a negative out, the two terms flip. So if I put the negative in, the two terms flip. And, you know, the thing to the right of that line is preferable because there's fewer negatives, that's all. I mean, if I gave you this, and I said, you know, simplify something, and you got the following, you wouldn't write that. You'd cancel all the negatives. So fewer negatives is better. Is that okay, Shannon? Okay. I do want to move forward here because we have a, not necessarily a very challenging lesson, but a lesson that is more challenging. So far, it's about factoring and canceling, and that is about to change. Okay? And this is where the wheels don't necessarily fall off the bus, but they start to get a little wobbly for some people. We're going to be looking today at adding and subtracting rational expressions. Remember, everybody, that rational expressions are just a type of fraction. So we're talking about adding and subtracting fractions. And with that in mind, we're going to start off by simplifying, and this is really just review, 5 over 8 plus 7 over 8 minus 3 over 8. And that's really what we have here. But let me rewrite this and tell you that if I were teaching junior high or elementary math, and I were teaching students how to add and subtract fractions, I would never say, ever, 5 over 8 plus 7 over 8 minus 3 over 8. I would say 5/8 plus 7/8 minus 3/8. That's what's going on here. And you don't have to write this. But 5 over 8 is 5/8. And 7 over 8 is 7/8. And 3 over 8 is 3/8. And I've used this analogy enough that it should make sense to you. First of all, that's no different than 5x plus 7x minus 3x. It's no different than 5 kittens plus 7 kittens minus 3 kittens. We won't worry about where the 3 kittens went. But we had 5 and we added 7 and we gave 3 away. You're going to be left with, I better get this right, 9 kittens, wouldn't you? Because 5 plus 7 is 12, minus 3 is 9. So when you have 5/8 plus 7/8 plus 3/8, and you certainly don't need to write this down, what we have is this. I mean, this is how I would teach fractions to elementary students and junior high students. We wouldn't start off with cardboard cutouts and shapes, and I wouldn't use rules. I would say that's what's going on. You have 5 of these, you're adding 7 of them. Have I got 7 there? Yep. And you're taking away 3. So the bottom line is you get 9/8, right? Are you with me on this? Okay. So how is it you get 9/8? Well, the rule is you put them all over 8 and you say 5 plus 7 minus 3. This is why when you're adding fractions that have the same denominator, you don't add the denominators. The denominator stays the same and you add the numerators or subtract or add or subtract. So the answer is 9/8. And really that's such a simple question. So what happens then if I say to you for review 2, simplify 5 over 4 plus 7 over 8 minus 2 over 3? Well, the answer is we can't add them. And you don't have to write this down. In fact, I kind of hope that you don't. You can't add these because you're taking quarters and adding eighths and taking away thirds. It's like me saying simplify that. Well, you can't simplify. You got 5 cats, you have 7 mice, which is maybe asking for trouble, but you have 5 cats and 7 mice and $2. There's nothing you can do with that mathematically. By the way, when I write this 5 times a quarter, that's not what we're going to be doing. That's just me explaining fractions. So this is where the concept of a common denominator comes in. So what we want to do is rewrite, let me write this down, 5 quarters, 7 eighths, and 2/3. I just need a little more room. 5 quarters plus 7 eighths minus 2/3. We need a lowest common denominator, and maybe this will be the first time in your math career where you're taught what it actually is. I mean, maybe not, I don't know. What would our lowest common denominator be here? And I'm not, to be honest, and don't take offense to this, I'm not very hopeful that everybody knows it right off the bat. Some of you are really going to struggle with coming up with this. I am looking for a number, and if you get it, that's fine. I'm looking for a number that we can arrive at for all 3 of these denominators, 4, 8, and 3, that we can arrive at by multiplying the old denominators by some numbers to get the new denominator. But how many of you were taught this trick, that you could go 4 times 8 times 3 and use that as a denominator? Don't. You do that with rational expressions and you are digging yourself a very deep hole. So I'm going to leave that question in your mind for a minute. What is the lowest common denominator? How many of you have it? Okay. Another way that you can think of this, although we're not going to think of it in either of these ways, is you could say it's also called the least common multiple. So you could start looking at all of the multiples of 4, all of the multiples of 8, all of the multiples of 6, and keep going until you get the same multiple. Lucas, what is it? It is 24. But I want to show you something. And I'm going slow here intentionally because things are, believe me, going to get difficult here. And again, I'm just trying to prepare you. What are we supposed to do with fractions in this unit? Factor them. Yeah? We're supposed to factor them. So if I were to factor this, it's 5 and 2 times 2. And this is 7 times 2 times 2 times 2. And this is 2, and it's over 3. Are you with me on that? Okay. Here's a surefire way to find a lowest common denominator. Your lowest common denominator must contain all of the factors in each of the old numbers. Let me explain what I mean by that. Look at the first denominator. The first denominator has 2 factors of 2. Okay? That means your lowest common denominator must contain 2 factors of 2. It has to. And that means now that this is represented in our common denominator. We're done with it. We move on to the second denominator. The second denominator contains 3 factors of 2, which means that our common denominator has to contain 3 factors of 2, but we already have 2 there. So now I say, well, okay, if I put a third one here, then this is represented. Our third denominator has a factor of 3, which means we need a factor of 3 here. Well, guess what 2 times 2 times 2 times 3 is? It's 24. And this will always work. And I know that some of you, all of us, got frustrated in fractional math where you're trying to find a common denominator, and it's confusing, right? Let's finish this off, and then I'll make up one more. So this line here is not what you would write necessarily with numbers, number fractions. What you would do is you would figure out it's 24, and then you would say, I need to multiply top and bottom of this by 6 to get 24. I need to multiply top and bottom of this by 3 to get 24. And I need to multiply top and bottom of this by 8 to get 24. Are you with me? Okay, but look, and I'm starting off simple for a reason. You just have to trust me. That means that we're multiplying by 2 and 3 on the top and bottom here, because we have to have all of these factors, 2, 2, 2, and 3, but there's only a 2 and a 2. We're adding those extra factors that are missing. We're multiplying here by 3 and 3 to get all 4 of those factors. We're multiplying by 2 times 2 times 2, and I better get this stuff out of the way. We're multiplying by 2 and 2 and 2 to get those factors. And this is how I would prefer that you think of things in a few minutes. That it's not necessarily that you're converting to a common denominator. You're ensuring that all of the denominators have all of the same factors. Anyway, these are all over 24 now. We have 30 over 24. We have 21 over 24. And we have minus 16 over 24. How's my multiplication there? Good. Which means we have 30 24ths, 21 24ths, and we're subtracting 16 24ths. So whether it's 24ths or cats or pesos, it doesn't matter. We can just add 30 plus 21 minus 16 and give us 35. Thank you. 35 over 24. So it's a very powerful idea. I'll give you another quick illustration and then we'll get back to the lesson. If I said to you, what's the common denominator here? I better not do that. What's the common denominator here? That is a complicated question, isn't it? You go into a grade 8 class and you want to watch their little brains start melting down. Ask them to find the common denominator. Half of them will put their heads down right away and close their eyes. It's difficult. But if you know the secret, it's easy. 28 is 28 is 4 times 7. 4 is 2 times 2. So that's 28 in factored form. 18 is 9 times 2, which is 3 times 3 times 3. Sorry, 3 times 3 times 2. It's in factored form. Our lowest common denominator has to contain a 2 and a 2 and a 7. Otherwise, this is not represented. It must contain, looking at our second fraction, it must contain a 3, a 3, and a 2. But I already have a 2. So there's an overlap here. That's where the word common comes in. So what is this? 36 times 7? 252. Am I right? You could play around with those numbers for an hour. And unless you're willing to write multiples of all of them and continue doing it that way, you're never going to figure out that it's 252. But the lesson here, everybody, is you have to look at the factors. All right. So, write a rule used to add or subtract fractions. You need a common denominator. And you add or subtract the numerators. I don't want to spend a lot of time writing out words. That's the bottom line. Each fraction has to have the same denominator, and your answer will be a single fraction with that common denominator, and the numerator is going to be whatever the sum and difference of all of the numerators is. It's different than multiplying. Multiplying, you multiply across the bottom, you multiply across the top. Adding, you get the common denominator, and you leave that denominator alone. You add across the top, though. Well, we're going to do the same thing with rational expressions. Okay. However, let's start with this one. We need a common denominator, don't we? Do we have any work to do here to find the common denominator? It's done for you. And I'll be honest, I don't think I'd give you this on an exam. This is just warming us up. These are both over 2y, so I can write 3x plus 5x plus 6 all over 2y. So I add the numerators, I write it over the common denominator, which gives us 8x plus 6 over 2y. Any questions? Is that our answer? Well, what we have done is we've created a rational expression, haven't we? A single rational expression. And the expectation is that you always simplify answers. So how do you simplify a rational expression? Factor and cancel. Can we factor anything here? Well, 8x plus 6 is factorable. I can take a 2 out of 8x plus 6 and be left with 4x plus 3. And this is over 2y. Can I cancel those two 2's? Yes. Because even though I don't need to, I could put a set of brackets around that 2. And I think we had this conversation yesterday, didn't we? That 2y is a factor of the bottom, but that means 2 and y are factors of the bottom. So this cancels, and you're left with 4x plus 3y. Sorry, you're left with 4x plus 3 over y. I'm not really in a big yank today to worry about non-permissible values, but there it is. Okay. Well, this is ridiculously easy. These are both over b minus 2. So I have 3b plus 2b minus 10 over b minus 2, which gives me 5b minus 10 over b minus 2. By the way, b cannot be 2. Are we done? No. Factor. You know what this is like? This is like when you were doing work with radicals and you would put radicals together and then you go, oh, I'm done that question. But then you'd see a radical in your answer like root 18, which could be simplified. And you didn't have it before because maybe it was, root 6 times root 3. You always want to check to see if you can continue to simplify. And for rational expressions, you factor. We can take a 5 out of the top and cancel. So that whole b minus 2 is gone. The answer is, and this is weird, 5 as long as b is not 2. And I know that's weird because there's no b anymore. But we have to put it. Speaking of b's, any questions with b? All right, one more. Like this is going to be p squared minus 7p plus 12 all over p minus 4 because the sun shone on us in this example by giving us a common denominator right out of the gate. But that numerator is factorable into p minus 4, p minus 3. This is over p minus 4. P minus 4's cancel. All you're left with is p minus 3 on the top. But again, p is not equal to 4 because of the p minus 4 that was there. And before we go on, I just want to make sure you understand something. What happened in A was we were able to factor and cancel to get a simpler result. That happened in B, and that also happened in C. I don't want to give you the impression that it's always possible. Sometimes it just doesn't happen. Okay? I mean, let's face it, in this question, if I would have changed this to 5, you wouldn't be able to factor it. All right, so what's the lowest common denominator? I need you to understand something here to appreciate the time we spent at the beginning of this class. If I didn't talk about those review 1 and review 2, especially review 2, and I said, what's the lowest common denominator here? I already know many of you still can't get it. That's not an insult. It's just the fact that it's new. What you want to do, well, I'll ask, how many of you feel as though you know what the lowest common denominator is? Like for sure. So a couple of the hands just kind of dropped a bit when I said for sure. Let's find out. This is 3x over 2 times x times y plus 5x plus 6y over 3 times y times y. How many of you now for sure know? Okay. So your confidence goes up. And then when I tell you that your lowest common denominator has to contain representation for each of the old denominators, it becomes a little bit easier. The first denominator is 2xy, so we need a 2, we need an x, we need a y. That denominator is represented now. The other denominator contains a 3, so we need a 3 here. It contains a factor of y, so we need a factor of y, and it contains a second factor of y. But there's an overlap here because we already have that first factor of y that was really the factor of y in the first denominator. So just maybe as a visual, right? There's an overlap. Some of you I know when you were doing fractions in junior high and other grades, you would just automatically multiply the denominators together. If you do that here, you get too big of a denominator and it won't work. It gets too complicated. So the lowest common denominator is 6xy squared. How many of you saw that to begin with? Good. 2 times 3 is 6, and then we have an x and a y squared. So I'm going to rewrite this again, and I have to pay more attention to my work here. When you write this, and you're adding or subtracting, always leave some air after each rational expression. Okay? Don't crowd things in. And one final comment before I finish my explanation for this. You certainly do not need to write the 2xy the way I did, and you don't need to write the 3y squared the way I did. Okay, so there's our lowest common denominator peeking up at the top. There are all of the factors. What do I have to multiply this denominator by to turn it into the new denominator? Well, I just have to add all of the factors that aren't there, that are in my common denominator. I need a factor of 3 and another factor of y. So I multiply the top by 3y. Here I'm missing a 2 and an x. So I multiply the top by a 2 and an x. And notice I put the 5x plus 6y in brackets. So just as a double check, and you will get better and better at this, if I put these over the same thing and I figure out what this is, I better get the same thing as when I figure out what this is. Right? They have to be the same denominator. And they're both 6xy squared. So this is over 6xy squared. And I have 3x times 3y plus 5x plus 6y times 2x. So I'm going to pause there and see, does anybody have any questions? The golden rule here now is you multiply out and simplify the numerator, but you're doing so in the hopes that when you get to the end of that simplification, you can factor it. Okay, but you can't see if it's factorable until you clean this mess up. 3y times 3x is 9xy. 5x times 2x is 10x squared. 6y times 2x is 12xy. Double check those. This is over 6xy squared. I can simplify the top a little bit further because I have these two terms, which are common terms. I have 9xy's plus 12xy's is 21. 21xy, so I have 21xy plus 10x squared over 6xy squared. Miles. Absolutely. And that's that thing. It's not always going to happen. But I said that you have to, if you take a look at the line at the top of the screen right here, you have to multiply that mess out to see if there's something you can factor out. By the way, Miles, you and maybe a few other people could recognize that you could take an x out of the top at the top line. I could factor an x out here and here. But a lot of people won't see that. But yeah, now we look at the result, which is at the bottom of the screen, and we say, can we simplify? Well, we're back to day one. How do you simplify? Factor and cancel. And there's a common factor of x in the top. And it's over 6 times x times y squared. So x is a factor in the numerator and denominator. We can cancel it and get 21y plus 10x over 6y squared. course, x and y are not allowed to be 0. So we need to find the common denominator. These two fractions are over different things. I'm curious, how many of you feel as though you know what the common denominator is? Would it be safe to say that the only reason you know what the common denominator is in one way or another you factored something? We'll just check. Miles, what do you think the common denominator is? And why is the common denominator b squared minus 9? You're correct. See, this becomes the question, and I'm going to explain why it's b squared minus 9 in a second, but if you're saying it's b squared minus 9, don't write this down, please. We're going to leave some air. Well, you're not writing it down, so it doesn't matter. If you're saying it's b squared minus 9, then you better be able to tell me what you multiply the top and the bottom of this expression by to get b squared minus 9. B minus 3. So, the few people that got it, I think you're kind of factoring it or you understand conjugates here, but what is the first thing you're supposed to do in every question in this unit so far? Factor. And you cannot see what the lowest common denominator is until you factor this difference of squares. Leave some air. Well, you don't really need to in this particular case, but and then we have 2b minus 10. I guess we can factor out the 2 here, although it's not really helpful. So our lowest common denominator must contain all of the factors in the first fraction. It has to. That's the rule. So we need a b plus 3 and a b minus 3. We got it. It's right here. But our lowest common denominator also has to contain all of the factors in our second fraction. The second fraction has a denominator of b plus 3. Well, that's okay. We already have the b plus 3. If you double up on it, it's going to get ugly. And that means that I have to multiply the top and the bottom of this by b minus 3. And we can put these together now. This is over b plus 3, b minus 3, and we have 3b minus 2 times b minus, that's not b minus 10, is it? It's b minus 5. We'll see, Zoe. I factored the 2 out, and I wrote 10 here. This is a 5. And then times b minus 3. So you now need to simplify that numerator. This is over b plus 3, b minus 3. I have 3b minus 2 times b minus 5 times b minus 3. Listen. When you multiply 3 things together, you have to pick 2 of them and multiply them together, and then take the result and multiply by the third. If I tell you to multiply 2 times 3 times 4, you can go 2 times 3 is 6 and then multiply by 4. Or you can go 3 times 4 is 12 and then multiply by 2. So I am going to multiply out the foiling aspect first. I'm going to multiply out this. b times b is b squared. b times negative 3 is negative 3b. b times negative 5 is negative 5b. So those come together to give negative 8b. And then the negative and the negative multiplied together to give you positive. 5 times 3 is 15. So we're getting close here with this one. 3b. When I multiply this through, I don't know that this has actually come up in this course yet. When I multiply that through, don't think of that minus as minus. Think of it as a negative that is connected to that 2. It's negative 2 times everything. Otherwise, you have minus 2 times all of that. It gets a little messy. Negative 2 times b squared is negative 2b squared. Negative 2 times negative 8b is 16b. Negative 2 times 15 is negative 30. How's my multiplication? Good. Over b plus 3. b minus 3. So close. Let's bring those b's together and write this in standard form. Negative 2b squared plus 19b minus 30. Are we done? This is an interesting question that I'm asking because the answer might be, it may be yes. But we won't know if we're done until we try to factor the numerator to see if something cancels in the denominator. I'm going to factor a negative out of the numerator because I don't like that negative b squared. If I say to you factor the numerator and you're looking at that, and you're like me, you go, I don't want to. But if I factor a negative out and have 2b squared minus 19b plus 30, yeah, you still may not want to, but it would be a little bit easier to factor that. But there's no guarantee that it's factorable. So I would like everybody to calculate the discriminant, which tells us if something is factorable or not. I don't think it is, quite frankly. Man, it's factorable. I'm surprised. Two B and B. Oh, there we go. Just about had it. No, that won't work. Has anybody got it?
Couldn't you before do it, factor that before you start multiplying?
For here?
No, go up. Keep going. Right there, b negative 3, b negative 3. Top and bottom.
No. Because this is a factor of this term, but not a factor of that term. The thing that you're wanting to cancel, b minus 3, and then we'll get back to it, it needs to be in brackets and then multiplied by the whole rest of it. There can't be any plus or minus in there. No, it's not 15. 10, 2, 10, 2, 6, and 5. Man, why can't I get this? Was 15 and 2? Oh, yeah. No. But if I go 15 here, if I go 15 here and 2 there, does that give me, oh, it does give me negative 19. I just couldn't add. That's right. By the way, now we get to the heart of the matter, b plus 3, b minus 3. Does anything cancel? No. So, this is tricky. If you said this is your answer, you would be right. Because the only reason we really want to factor it is to see if something cancels, and since nothing cancels, we could end there. But you won't know unless you factor it. Okay. One more to go. And then I'm not exactly sure of what our plans are for tomorrow. Tomorrow we have our seminars the next day, right? I think I would like to have a short quiz in our seminar the next day, and I think tomorrow might be a work day where we work on this stuff. I have to check the schedule for the unit and make sure that doesn't put us too far behind, but I think this is important enough to slow down. So what's the lowest common denominator? There's nobody that can see what the lowest common denominator is here without factoring. Okay. So we have x minus 1 over, we're going to factor this, two numbers that multiply to give negative 6 and add to give positive 1 would be 3 and negative 2. Leave some air there, minus x minus 2 over two numbers that multiply to give 3 and add to give 4 would be these. So I would like everybody to give some thought as to what the lowest common denominator is. Jack, you still with us? Thank you. Well, starting with the left-hand fraction, the lowest common denominator needs a factor of x plus 3 and a factor of x minus 2 because those two factors are in that denominator. Going to the next fraction, we have two factors as well. I'm looking here right now, x plus 3, but we've already included it. It's already there. And then we also need an x plus 1. That means that I have to multiply the top and the bottom of this by whatever factor it doesn't already have. And it does not have an x plus 1. So now it will. I need to multiply the top and bottom of this by the missing factor of x minus 2. Now I can put them together and have the whole thing over x plus 3, x minus 2, x plus 1. Just one final note here before we polish this off. I'm sure many of you recognize that in going from here to here, we could have multiplied out the x minus 2, x minus 2. And you can feel free to do that. Same with the x plus 1, x minus 1. Okay, let's FOIL this out. X plus 1, x minus 1. Well, that doesn't require FOILing because they're conjugates. It's a difference of squares. And then minus x minus 2 times x minus 2 is x squared minus 4x plus 4. My outer will be negative 2x. My inner will be negative 2x. So I get negative 4x over x plus 3, x minus 2, x plus 1. Are you okay with that? Only one person is not? Sasha?
I think that you have the negative 4 and it's supposed to be a positive 4x, and the positive 4 is supposed to be a negative 4.
I'm missing my x, is that what you're saying?
Yes, and the negative 4 should be positive and positive 4.
Okay, so what I'm missing, and you're one step ahead of us, but what I'm missing is brackets, right? Okay, you need to put brackets there. And I apologize for not writing an x. That wasn't what I was referring to. I was referring to the fact that this is what's going on. And Sasha, I think what you're doing is you're saying it's x squared, but I'm subtracting it. It's negative 4x, but I'm subtracting it, making it positive. Okay, is that what you're saying? Okay. So now we just have to simplify this. I have x squared minus 1, and then I have minus x squared plus 4x minus 4. So I just want to check, Sasha, this is what you would have written. Okay. Over our denominator. So we can simplify that numerator into x squared minus x squared is nothing. We have 4x and then minus 5 over our denominator. And you can't factor 4x minus 5, so the only factor in the top is this, 4x minus 5, and there isn't an identical factor in the bottom to cancel. So we're done. I know that somewhere along the way I've neglected my non-permissible values, but I don't want to go back and do them. Okay? I don't know whether it was the example before this or the one before that, but it's not important today. It's a totally different set of steps here today compared to what we've been doing. Factor so you can identify the common denominator, convert each fraction to the common denominator, and then put them together over the common denominator, and then add and subtract the numerators, and then see if you can simplify the result. There's a lot more going on here. So page 336, 1, 3, 5, 6, and 7. We got lots to work on. I'm just going to go to my computer right now and check the calendar and see what we have for days, because I think this is important enough that I don't just give you 20 minutes to work on it. But we'll start with 20 minutes, okay? And I'll be right back and I will help you out.